The International Space Station has less than 5 years left before it plunges into the Pacific Ocean. NASA's already chosen its replacement, a private company called Axiom Space that struggled to pay nearly 1,000 employees just months ago. Yet somehow, this same company just completed the world's most powerful commercial space station module, equipped with 32 Mark 8 engines designed to move the entire structure without help from visiting spacecraft. How did a company on the brink of collapse become SpaceX's chosen partner for humanity's next home in orbit? And what makes their design so radically different from the ISS that it could operate at 1/3 the cost? Let's dive right in. Michael Suffredini spent 3 decades at NASA, managing the International Space Station from 2005 to 2015, the critical years when it transitioned from construction to full operations. In 2016, he partnered with billionaire Kam Ghaffarian, who ran NASA's second-largest engineering contractor, the company responsible for astronaut training and ISS operations. These weren't newcomers dreaming big. They were insiders who knew exactly how space stations worked and what mistakes to avoid. So what went wrong? By early 2024, Axiom had nearly 1,000 employees on payroll, all hired to meet an impossible deadline, launching their first module to the ISS within the year. The company was burning through $10 million monthly just on salaries. But here's the catch. Most of those engineers had nothing to build yet. Axiom hired faster than they could manufacture hardware, and the cash reserves evaporated. The company laid off roughly 100 employees and even floated the idea of paying remaining staff partly in company stock just to prevent a mass exodus. Was this the end of NASA's best shot at replacing the ISS? Then something shifted. By mid-2025, paychecks started arriving on time again. In July, Axiom posted an update that caught everyone's attention. Their Italian partner, Thales Alenia Space, had completed all primary welds on the payload power thermal module in just 250 days. That's 8 months from first weld to final weld, an achievement that proved their international partnership wasn't just surviving, it was delivering results ahead of internal expectations. 1 week later, they announced the forward and aft sections were being connected for flight certification tests before shipping to Houston for systems integration. After 4 months of silence, that module is likely deep in the testing phase right now, preparing for an 18 to 24-month integration process in Texas. If everything holds, the PPTM launches in late 2027 aboard a SpaceX Falcon 9. But why is this particular module going up first instead of the habitat where astronauts will actually live? The answer comes down to docking logistics and power requirements. Originally, Axiom planned to send Habitat 1 first, docking it to the forward port of the ISS. But NASA reserved that same port for SpaceX's deorbit vehicle, the spacecraft designed to safely bring the ISS down in 2030. Moving docking adapters around would take months and cost millions. The PPTM solves that problem by docking to the nadir port of Node 1 or Node 2, positions typically used for cargo vehicles. This means it can coexist with the deorbit spacecraft without blocking critical pathways or requiring expensive reconfigurations. Even better, the PPTM immediately provides power, thermal control, and payload capacity greater than Habitat 1 could offer. It acts as the station's beating heart, delivering electrical power and cooling at levels comparable to the entire ISS through red wires, roll-out solar arrays, and radiator-based thermal systems. It also carries 8 science racks for research equipment, allowing NASA to transfer experiments from the aging ISS to Axiom Station without interrupting decades of microgravity research. And those 32 Mark 8 engines? They're powerful enough to boost the entire station's orbit without relying on visiting spacecraft, a capability the ISS never had in a single module. How much does that kind of independence change the game for commercial space stations? Once the PPTM is operational in orbit, Axiom will launch 4 more modules: Habitat 1, an airlock, Habitat 2, and the research and manufacturing facility. But the 2 that define what this station will actually become are the habitats, the spaces where people will live, work, and look down at Earth from 250 miles up. Habitat 1 launches in 2028, an 11-meter-long cylinder with 4.2 meters in diameter, giving it roughly 50 to 60 cubic meters of usable volume, enough for a crew of 4. Inside, each astronaut gets a private crew quarter with a large Earth-facing window, touchscreen communication panels, and enough personal space to feel human again after months in microgravity. The galley includes a microwave and specialized fridge. There's exercise equipment like a treadmill and vibration-isolated stationary bike to counter muscle loss. ARHI-1 also features independent navigation and control systems, plus its own thrusters for orbit adjustments, meaning it can function like a standalone spacecraft rather than depending entirely on ISS infrastructure. 4 radial ports allow connections to future modules and docking for visiting vehicles like Crew Dragon. When the ISS deorbits in 2030, HAB-1 detaches and continues operating independently. How many times in history has a space station been designed to literally separate from its parent structure and fly free? Habitat 2 arrives in 2029, bringing major upgrades that push the station into true long-term sustainability. Its environmental control and life support system recycles 98% of water and air, significantly better than the ISS's 90% recycling rate. That might sound like a small difference, but over months and years, that extra 8% means fewer resupply missions, lower costs, and genuine operational independence. HAB-2 also carries high-speed commercial satellite communications for real-time data transfer and its own remote manipulator system, essentially a robotic arm similar to Canadarm3 that can assist with module assembly or perform external maintenance without requiring spacewalks for every minor repair. With HAB-2 online, total crew capacity jumps to 8 people, doubling the station's operational potential. At that point, Axiom becomes more than a research lab. It becomes a multi-purpose platform for government science, space tourism, and commercial manufacturing. The ISS modules like Destiny and Harmony are larger, but built with rigid, highly interdependent systems that require constant support from other modules and visiting spacecraft. Axiom's approach is fundamentally different: modular, detachable, expandable without major reconfiguration. From day one, they designed this station to operate on an economic model where government research shares space with paying customers and private missions. That's how they project operating costs at roughly 1/3 of the ISS while maintaining high-end scientific capability. Blue Origin's New Shepard gives passengers a few minutes of weightlessness before falling back to Earth. Axiom offers an entirely different experience: days or weeks living as an astronaut, sleeping in a private room with Earth rotating below your window. For space tourists willing to pay, that's not just a different product. It's a different category entirely. And SpaceX's role in all of this? It goes far beyond just launching modules. Axiom signed contracts back in 2020 and 2021 to use Crew Dragon for all their crewed missions from Axiom 1 through Axiom 4. Recent updates show SpaceX is considering Starship for Axiom's larger future modules, like the research and manufacturing facility, since Starship can haul over 100 tons and operates as a fully reusable system that could slash long-term costs. There's no firm schedule yet. Starship is still in testing, but Axiom has already locked in Crew Dragon as their primary crew shuttle. In a few years, SpaceX's manifest will be packed with ISS support missions, vast station launches, and Axiom flights. The logistics alone seem overwhelming, but for SpaceX, it's profitable chaos that multiplies their influence across the entire commercial space industry. But Axiom isn't just building a space station. They're also developing the Axiom Extravehicular Mobility Unit, the next-generation spacesuit designed specifically for NASA's Artemis missions on the Moon. On November 20th, 2025, this suit passed its first thermal vacuum test inside KBR's lab in San Antonio, Texas, the same facility that once trained Apollo astronauts. It's already completed underwater simulations that push suits to their limits. If water can't penetrate it, lunar dust won't stand a chance. The suit features advanced materials rated for extreme temperatures, a modular design that adapts to different mission profiles, and the ability to fit a much wider range of astronaut body sizes than previous suits. Why does a company building a space station also need to design spacesuits? Because Axiom isn't just replacing the ISS, they're building the complete infrastructure for humanity's next chapter in space. A station that can sustain itself without constant resupply, Spacesuits that work on the moon and eventually Mars. A business model where governments, corporations, and private citizens share the same orbital platform. This is what happens when a company survives its worst moment and comes out focused on what actually matters. 5 years ago, the ISS replacement seemed like a distant problem. Today, primary welds are complete, engines are being tested, and launch contracts are signed. The station that nearly died from overhiring and cash burns is now on track to launch in 2027. SpaceX didn't choose Axiom because they were perfect. They chose them because they had the right people, the right experience, and the ability to learn from catastrophic mistakes without giving up entirely. That's rare in any industry, but especially in aerospace where failure often means the end of the company. So when the ISS makes its final descent in 2030, humanity won't be watching the end of permanent presence in space. We'll be watching the transition to something better, cheaper, and more accessible. The question now isn't whether commercial space stations will work. It's how many will we need? What do you think? Can Axiom really pull this off on schedule? Drop your thoughts below, and if this breakdown changed how you see the future of space stations, hit that like button and subscribe to Space Update 24 Hours for more deep dives into what's actually happening beyond Earth. We'll see you in the next one.